All right, today I am going to talk to you about a couple more conjectures. Okay, we have learned the rules of kites and trapezoids. Okay, and today we're going to learn about parallelogram rules. Okay, and mid-segment rules. Okay, to quick review here with you on our kites and trapezoids. We know that our non-vertex angles are congruent. We know the diagonals are perpendicular. We know the non-vertex diagonal is bisected, okay, by the vertex diagonal, okay, and the one we typically forget is the vertex angles are bisected by the vertex diagonal, okay. In a trapezoid, okay, the thing that we need to remember is the angles between the bases have to add up to 180 degrees. So angle A plus angle B have to equal 180 degrees. Angle C plus angle D have to equal 180 degrees. Okay, now if it's isosceles, okay, the rules still occur right here. These angles right here are still going to be supplementary to one another. Okay, but if it's isosceles, these base angles, okay, right down here are going to have the same measure. Now in a trapezoid, you don't always have to have the small base up on the top, so you do have to look at both sets of base angles having the same measurement. Okay, and then one additional rule right up here is that the diagonals, okay, will both have the same length. Okay, so there's a couple rules about trapezoid. Okay, so now what we're going to go into here is there's going to be 4 rules about a parallelogram. Okay, and I'm going to use, just like I did with the kites and trapezoids, I'm going to use my Sketchpad program, which is very similar to GeoGebra, in finding out, and many of you when we were doing proofs, okay, kind of knew about these rules, but I said, well, we hadn't formally formalized that these were what we call conjectures. Okay, so if we were in person right now, we would be able to put these into our notebook, and we would call them, conjecture 68, conjecture 69, conjecture 70, and so forth. Okay, but you can see right up here that I do have a parallelogram. What is a parallelogram again? It is when opposite sides, okay, are parallel. And you can see right now that when I'm making these sides will never intersect. Okay, now these sides don't all have to be the same length, but the one thing you do notice here is that these two opposite ones right here and these two opposite ones right here, when I do move these around, okay, you can notice, okay, those measurements right there, no matter if it's long and skinny like that, okay, or if I make it a little bit wider like this, okay, these sides that are opposite right here are going to be, okay, equal to each other. Okay, now it's not just the opposite sides that are going to be equal, okay, but, okay, if you look here at the opposite angles, okay, so when I make, okay, this parallelogram, okay, you look at these opposite angles right here, okay, angle CAB and angle CDB are equal to one another, and angle ABD and angle CACD are going to equal each other. So basically, when we're looking here at our rules right up here, the 2 rules that we're going to have, okay, and I said there's 4 of them, and these are 2 of them, okay, is the opposite sides are going to have the same measurement, okay, and the opposite angles are going to have the same measurement. Okay, so there's 2 of the 4 rules about a parallelogram. Okay, there are 2 more of them that are in here, and okay, of these 2 right here, okay, we have, okay, one of them here that has to deal with the diagonals. Okay, and the diagonals here, okay, as you can see as this moves around, okay, this is a parallelogram. Okay, so as they do move around, okay, I did measure, and this says HI, which is that length right here, is 2.39, and H, I guess I have 2 H's here, but that's this piece right here, okay, is 2.39. I don't know why I have 2 H's. Okay, but this right over here, this must be J. Okay, right up here, if I go get the little alphabet thing right here, yeah, that's J. Okay, right there. Okay, I could probably change, okay, this H, okay, right here, okay, to, let's just call it a W right now. I think it'll change the label in there as well. There you go. So that's WH is 2.39 and HI is 2.39. GH is 4.33 and HI is 4.33. And it doesn't matter what the size of this parallelogram is. Okay, you can see as that moves around. Okay, those diagonals are basically, and the words to this are the diagonals of a parallelogram bisect each other. And that's the part you want to write down in your notes. Okay, because that's the part on a quizzes is that'll come up in words. Okay, the diagonals of a parallelogram blank each other. Okay, well, the diagonals of a parallelogram are going to bisect each other. So how do I go about drawing that one here, though? Okay, if you were just to draw it, I would come up here and I'd say, oh yeah, that diagonal and that diagonal, okay, are going to cut each other, okay, in half. Okay, so if this whole diagonal right here was 10 centimeters, then that's going to be 5 and 5. If this whole diagonal right over here is 12 centimeters, okay, then this is going to be 6 and 6. Okay, so the diagonals of a parallelogram are going to bisect each other. Okay, we know that opposite sides are equal. We know opposite angles are equal. And there's one more, okay, that we have for a parallelogram. Okay, and in a parallelogram right here, it's a simply put right here, and you can see this no matter what I put right up here. Okay, if I add these two angles together, which I actually did right over here, okay, I added them together, and notice they can't come up to 180 degrees. 46 plus 134 is, okay, 180. Now notice these angles right here are changing. That's 54 and that's 126. But notice that sum right there stayed the same. Okay, so just like a trapezoid, okay, where I said the angles between the bases equal 180, okay, well, that's not only true here. I can come up here and I can measure not just the angles between the bases, but any consecutive angle in a parallelogram. Okay, notice this one right over here. Those are consecutive angles. They add up to 180. Okay, if I come over here and I add together, okay, this one right here plus that one right there, they add together, okay, to equal, okay, 180. And even these bottom two right here, this one right here and that one right there, they're going to add together to equal, okay, 180 degrees. Okay, I can add together that one right there plus, okay, this one right over here. Okay, and you can see they add together, and no matter what size I make this parallelogram, you're seeing the angles are moving. Now don't look at my parallelogram getting bigger, but look at the angles right now. Okay, those angles are changing size. Okay, but you can see these sums right over here do not. Okay, so my fourth and final rule, okay, for this, okay, is going to state exactly what I did in the trapezoid one that I did right here. Okay, but these were not, okay, supplementary in a trapezoid, whereas, okay, when I'm over here in a parallelogram, okay, those are 180, okay, those are 180, okay, those are 180, and those are 180. Okay, not very pretty here to define it, so I'm going to actually write down the rules. Angle A plus angle B equals 180 degrees. Angle B plus angle C equals 180 degrees. Angle C plus angle D equals 180 degrees, and angle D plus angle A, okay, equals 180 degrees. Okay, so there's your 4 rules, okay, that you're going to have right there for a parallelogram. Okay, those are the 4 things that you may have on an entrance quiz when you come in tomorrow. So make sure you write those down and not only know the pictures, but how you'd say those in words. Okay, this one right here, how do you say that in words? Consecutive angles are supplementary. Write that down. Consecutive angles are supplementary. Okay, obviously this one was, how do you say that in words? Opposite sides are congruent. How do you say that one right there? Opposite angles are congruent. And how do you say this one right here? The diagonals of a parallelogram bisect each other. Okay, now there are 2 more rules that I have, and these 2 rules right here, okay, work for a midsegment. Okay, well, what is a midsegment? Okay, well, a midsegment, okay, can be drawn in triangles or it can be drawn in trapezoids. Okay, in this first picture right over here, we're going to talk about a midsegment in a triangle. Well, a midsegment is, okay, simply, okay, I'm going to find and construct a midpoint right here. I'll find and construct a midpoint to another side. Okay, whoops, need to clear it out there. Okay, construct a midpoint right over here. Okay, and if I connect, okay, these two midpoints, and yes, they're not midpoints unless I label, and you'll see right there, but that DE right there, that is considered a mid-segment, okay, because, okay, these segments, if I measure, okay, that length right there, oh yeah, that's 3.69, okay, and if I come over here and I measure from A to D, okay, oh yeah, that's 3.69. So D is a midpoint, okay, right there. And you can see as I move that around, okay, D stays right there as a midpoint. Okay, and E is going to do the same thing right over here. It's just saying this program does almost exactly, whoops, you don't want to know what I just did there. Okay, but this program does almost exactly the same thing as GeoGebra does. Okay, it has a better calculator on it here, so I chose to use this program instead of GeoGebra here. And typically we do this investigation a lot of times in class, okay, but since we are online, okay, and some of us in class, okay, I chose to just, okay, present this as an Edpuzzle here instead. And you can see this segment right here, okay, is what we call, again, a mid-segment. A mid-segment, by definition, is a segment that connects two midpoints. And what is true about the mid-segment? Okay, well, there's two things that are true about a mid-segment. One, okay, and this is the easy one right here, okay, that mid-segment right there will never intersect this base right down here. Okay, what do I mean by that? That mid-segment's parallel. Watch. If it's parallel, then this angle right here, okay, angle ADE, okay, well, it's 54 degrees. Okay, and the angle right down here is going to also be 54 degrees if that is parallel. Okay, because if you look at those two angles that I have right there, they're what we call, again, corresponding angles. Okay, and you can see if corresponding angles are congruent, then the lines are parallel. What is that again? That's called the converse statement. Okay, if corresponding angles are congruent, then these lines right here are parallel. Now you could have done it using these corresponding angles, or I could have came over here and I could have used, okay, this angle right here, AED. Okay, that measurement right there is, okay, going to be 19.59 degrees, and angle C will also be 19.59 degrees. Okay, the reason I know that is because, you know, all mid-segments, okay, or in a triangles are going to be parallel to one another. Okay, and now that's not the only thing that's going to be true here. Okay, the mid-segment is not just parallel, but there's something about its length. So when I come back up here and I look at, oh, my mid-segment in a triangle, okay, the first thing you can do is, in your first rule, you're going to say, oh yeah, I better write down that they're going to be parallel. Okay, so that is the first point that you would write down. Okay, now there's also something about the length of this mid-segment. So if I came over here and I said, oh yeah, this mid-segment right here is 12 centimeters long, you should be able to find out the length of this base if you know the mid-segment, or vice versa. If I give you the base, you should be able to find the mid-segment. Okay, and there is a relationship here, which we're going to find right now, okay, by measuring, okay, this mid-segment. So let's measure that mid-segment right there. And that mid-segment right there is 10.77 centimeters long. And let's measure this base right here. Okay, and that length right there is 21.54. And you're looking at these things saying, oh, I can't really tell it. Okay, maybe I could put some nice numbers here. There we go. Got 10. Oh, I had 10. But it's 10.01 and 20.03. Yeah, my slide of my hand. Now, if I do use my calculator, now watch this. This is kind of slick on this program. You don't have this in GeoGebra. But I can take this number right here, and I can times it by 2, and I guarantee I'll get that 20.03, and I did right there. Okay, because what I just found out is no matter how big, okay, no matter how big, no matter how small this mid-segment is, okay, that mid-segment right there is half as much as the base. The base is twice as much as the mid-segment. So if I come back over here and I say, oh yeah, this mid-segment right here is going to be 12 centimeters long, how long is the base going to be? oh yeah, that's going to be 24 centimeters long. Okay, and vice versa, I can come over here and if I give you, okay, the base, so if I gave you the base is 30 centimeters long, you're going to say, oh yeah, the midsegment is half as much as the base. The base is twice as much as the midsegment, so this is going to be 15 centimeters long. So what's the rule here is in a trapezoid, or sorry, in a triangle, okay, if you double the midsegment, okay, it's going to equal the length of the base. So here, 2 MKs will equal an HI. Okay, this first part that I put right here, that's your geometry setup. Okay, and then this part right here, you'd start putting numbers in there, okay, for your algebra setup. Okay, so that's what happens here when you're talking about, okay, the length, okay, of, okay, a midsegment, okay, when we have two midsegments equal the base. Okay, now I can come over here in a trapezoid, okay, and I can do the same thing. Okay, I have, okay, your midsegment of a trapezoid. Okay, so a midsegment of a trapezoid, okay, is going to be, again, connecting any two midpoints. So if I come over here and I construct, okay, a midpoint here, and I find a midpoint, okay, right over here. Okay, just a second, let me clear that out. There we go. Okay, so I construct a midpoint here. Okay, again, if I measure them, these are midpoints, A to E, construct, or sorry, measure that distance. Okay, measure E to C, measure that distance from D to F, measure that distance from F to B, okay, you can see those things right there are midpoints for sure. Okay, I'll put them right over here. There we go. We got, okay, midpoints F, and we have midpoint E. Okay, now, okay, is that going to be true about midsegment? Well, a midsegment is always, regardless of what type of, if it's in a trapezoid or whether it's in a triangle, a midsegment should always be parallel to its base. So what I'm going to do right over here, let's check it out here again. Okay, is it parallel to the base in a trapezoid? Okay, if I measure this angle right here, okay, that angle right there is going to be 49.71. Okay, and I measure from C, A, B, okay, is 49.71. Okay, and that's going to be the same thing right over here because those are corresponding angles. And because those are corresponding angles, we know no matter what type of trapezoid, again, this is a trapezoid, okay, right here, okay, because of that, okay, that midsegment, okay, is going to be parallel, okay, midsegment is, sorry, I got to get my pen here, parallel to not just one base, but both bases. Okay, now that's the rule for the being parallel to the base. Now there is also a rule about its length. Okay, so if I come over here and I look at, okay, the length of this midsegment, okay, if I measure that length right there, oh, that length right there, oh, not bad, about 3. Okay, 3 centimeters. Now if I measure this down here, you're going to say, oh yeah, if that's 3, this one's going to be 6. I'm sorry, I got to do some undo things. Wouldn't that be things I had some things undo here to undo? So let's try this again. I had something here highlighted, okay, when I did this. So let's measure EF again. So measure that length right there. So that sounds better. Okay, that is 11.46. Okay, now let's come down here, and if I'm thinking, oh yeah, this is twice as much, this should be 22.92. No, not even close. Okay, that's because the midsegment is not half as much as this base, because this is not the only base. In a triangle, there was only one base. Okay, there's the only base right there because the midsegment is parallel to the base. But in a trapezoid, the midsegment is parallel to both bases. So there's a relationship between its measurement of both bases. So if I came over here and I measure this one right here, okay, that right there is 8.33. Now if I came over here and I did my little calculator here again, and I said, oh, okay, what happens if I double this? If I times that by 2? Okay, oh, I'm going to come up with 22.91. Well, that's not, obviously, I told you it was not 22.92 when I did it in my head. Okay, but there must be a rounding here that's going on. Okay, well, that's not 22.91. That's 14.58. But this one's 8. Ooh, look at those two. Let's try adding those together. So if I come over here and, okay, hit calculate again, and let's add together these two bases. Ah, there we go. Okay, so this midsegment is not half the one base, it's half the size of these two bases added together. And you can see that's going to stay true if I make it bigger, okay, or smaller. Okay, so if I bring in, you know, my sides, change all of these numbers so they're different. Okay, yeah, those things are different. Okay, right there. But if I'm adding these numbers together, they're still, no matter what's happening, if you double this midsegment, you will get these two bases, okay, added together. So my last rule that I have right over here, okay, is going to be, again, if I have 2 times my midsegment is going to equal, okay, not just this base, okay, so not just that base, right, we'll call that one base 1 right there, but also this one right here, so base 1 plus base 2. So in our picture right over here, okay, we're going to have 2 times EF is going to equal BC plus AD. Okay, so that gets you right here through the conjectures that we learned here today. There were 4 rules that we have for a parallelogram. Opposite sides are equal, opposite angles are equal, consecutive angles are supplementary, and the diagonals of a parallelogram bisect each other. Okay, and that's for parallelograms. And then we went on further to learn about midsegments. The midsegment saying that this midsegment right here is parallel to the bases, okay, and also half the sum of the bases. So if you double the midsegment, you get the length of the base. Or if you cut the base in half, you get the length of the midsegment. Same thing over here, but you have to add the 2 bases. Okay, so you have to take those 2 bases and add, okay, them together to get that midsegment. I hope that helped you out. Okay, we'll cover more when we get in class tomorrow.